This is our magnetic levitation circuit. First we have the power. The power goes in through a diode. The diode is used to prevent overload of the circuit. It then goes to a voltage regulator here, and this voltage regulator regulates the input voltage to 5 volts because the Hall effect sensor over here uses a maximum of 5 volts, and we don't want to burn that out. So we have this red LED here. This LED is to indicate whether power is on as a circuit. Power is currently not on in the circuit. I believe there's an issue in some of the connections. I'm still working on checking some of those. We have the yellow LED. That LED basically indicates whether or not there is current flowing through to the electromagnet. The brightness of the yellow LED can also indicate the level of current. Both of those LEDs have a resistor in series. That's to prevent burning out the LED. For the op-amp, we use the LM358 op-amp. It's a general purpose one, but here we're using it as a comparator. The two input signals it's comparing are first the one from the voltage regulator and the other from the potentiometer. Potentiometer is used to change the power in this circuit. You would increase the power to levitate a heavier object, but you would decrease the power to levitate a lighter object. Then the output of the op-amp goes over to the MOSFET. Then after that, the MOSFET puts current going through to the electromagnet, allowing the electromagnet to have an electromagnetic field. Now, how the levitation itself actually works is the Hall effect sensor can detect electromagnetic fields. So first, since this has a little bit of a field by itself without any current running through it, the magnet will be attracted to it. And now the sensor, ideally, would pick up the field of the magnet getting near it, and the closer it is, it would increase the current in the electromagnet, thus repelling the magnet. So while the electromagnet is repelling the magnet still has its own attractive qualities going towards the electromagnet, which would allow it to levitate. And like I said, the potentiometer can be adjusted to do heavier or lighter objects, or once you have an object levitating, turning the potentiometer can change the distance from the edge of the electromagnet to the magnet itself. I currently have it off the apparatus because I'm working on some of these solders, but yeah, that's it.